Hello, everyone. This is the DBA Fundamentals virtual chapter. And I know you're all here to listen to Kimberly, but I'm going to take your time just for a moment and then I'll pass it on to her so she has the complete as much time as possible. We are here today to talk with Kimberly Tripp. She's going to speak about stored procedure optimization techniques. A little bit of housekeeping. Here are our organizers, our information here. Steve, Shane, Warwick, Kevin, and myself are all organizers for this group, and our respective Twitter handles are there. So if you have any questions or anything, you can reach out to us on that. The whole entire group, we have dbafund.org, which lists all of our upcoming sessions. Of course, this is one of the really big ones, and I'm really excited Kimberly's here. But you can also check out others as well. This, as well as like 4 years worth of content, is actually available on our YouTube site, so dbafundtube.org, and this will be available within a couple of days after the presentation. So within a couple of days, it'll be there for you. The group itself, we have a Twitter handle at DBAFun, and I have some more news about that coming up. We also have a Slack channel, so check us out there, and LinkedIn as well. So there's some great information and a lot of ways to get our list of sessions coming up and some great tips and tricks. We wouldn't be able to be here today without our sponsors, so let's go over them real quick. SentryOne has a great product for helping you build, test, document, and monitor SQL Server, as well as Azure and the Microsoft data platform. You can reach them online here, Facebook, Twitter, LinkedIn. They have a lot of resources online, SQLperformance.com, blogs.sentryone.com, where all of their team members blog. They also have a very handy-dandy resources page, which kind of grabs everything together for you, so it's all in one place. You can also go to answers.sqlperformance.com for some free query tuning advice. And they do have some downloads. First is the trial for their software, but also a free plan explorer, and it's wonderful to use. It's an add-on right into your Management Studio window, and it really lets you see the plans much better. It's fabulous. My mouse keeps moving. Anyway, our second sponsor is DBA Watch, and they're actually, it's a complete solution for database administration, monitoring, performance tuning, security, and license management. So it's not just monitoring, it's actually a complete solution. Scalable, and it's for SQL Server as well as Oracle and other platforms as well. You can look at them online at dbawatch.com, as well as Twitter at dbawatch, dbwatch. And then they also have helpful articles and blogs, and you can download a trial of their software as well. News for our chapter. Upcoming giveaways, we are actually giving away something every month through June. So January and February, we will be announcing those winners very soon, and there'll be a $100 gift card. I need to fix that again. It's not for everybody who attends. You actually get a chance at winning for every attendance you do. March will be the same thing. We'll be giving away for attendance, and also we'll be giving away something for Twitter and for email. So make sure you're watching our Twitter handle and make sure you're registered or subscribed to our email list, and we will be doing something with each of those so that we can give 2 other giveaways in March. It is also time for Past Summit to coming up later in the year. So they've started giving out their discount codes, and here is ours. This actually gives you a $150 discount. Every few months, the price raises, so make sure you get in as early as you can. Right now, with this discount code, you can get it for $16.49. We are a member of PASS, and we are one of many virtual groups. This is just a list of all of the virtual groups, so you can see the different breadth of specializations that they have, from application development to BI to the different languages. There's a lot of opportunities, so make sure you check out PASS and the multiple virtual groups they have. And they'll all have sessions like this. So upcoming, women in technology, data architecture, another one of ours, the Italian group, another women in technology. So you can see there's a lot that's coming on in March. And this isn't everything, but this is just the most recent. Another awesome opportunity that the PASS gives us is a global event called SQL Saturday, and it is a free learning event. I remember my first one, and it was they have such good memories with that one. These are events where speakers come and they're just normal DBAs like you and me, talking and presenting about a topic that they know and are passionate about. So it's a great way of having free learning and networking. That's a wonderful way of getting that information out. These are just the most recent. You can go to SQLsaturday.com and look at all of them. Lastly, our sessions are recorded, and you will have this with on our YouTube channel within a day or two at dbafuntube.org. All right, with that, I'm going to turn it over to Kimberly.
Okay, so I just need to set up my screen. And perfect. I have 3 screens, so sometimes it doesn't show the right screen, but I do have the chat window showing as well. So for those of you that do want to ask a question, I will try to address those during my presentation if I see them pop up in the chat window and they're not, 3 paragraphs long, because it might be a little bit difficult for me to read something really long. But if there's something quick and something that doesn't make sense and I see the comment in the chat window, I can probably address it during the lecture. I will try to keep the lecture to about an hour so that a lot of you can get back to your work and all that good stuff that I know you want to do, even though this is going to be way more fun than that. But like I said, you can ask questions. I'll stay for questions afterwards. I do have a bunch of extra slides that I put into the slide deck that I've hidden, again, just to keep us on track, keep us focused, and really allow me more time for the demo, because I think you guys will appreciate the demo more than anything else. So I would really recommend going back and looking through the slides. There's some hidden slides on my team at SQL Skills and some of the things we offer, and even how to get a free Pluralsight code if you're not already a member of Pluralsight. So just make sure you look at some of those hidden slides. So I'm just going to go straight in. I've been working with SQL Server forever. I love it. I have a great time working with it. And like I said, I don't mind questions. In fact, that's probably to me one of the most fun aspects of what I do, is just, hearing how people are using SQL Server and answering their questions. So diving right in, I've got, like I said, a bunch of hidden slides, even about some of the topics that are right here in my overview. So make sure that when you get the slide deck or download the slide deck, that you look through some of the hidden slides. All the links will be active so that you can go through and see what some of those resources are and all that good stuff. So I'm going to briefly talk about processing stored procedures and really about plan caching. And most people think that plan caching is a positive, and it is. Don't get me wrong. I'm not saying that it's a bad thing, but it can be bad. And there are some situations where certain types of plans, when they are cached, actually causes a lot of problems. And I say that some procedures can be bad, but I have to tell you guys, one of the reasons that I love this presentation is that I have never been to a client that didn't have this problem. This is probably one of the most common problems that I see at, different consulting sites, or when I talk to customers, when I speak at conferences. I really don't see databases that don't have problems with their stored procedures and plan caching. And understanding better how SQL Server caches plans and how you can better create more effective stored procedures so that certain, let's say, parameters or combinations of parameters that generate nice stable plans are cached, but where certain parameters that don't generate nice stable plans aren't cached is kind of a really cool thing you can do. You can actually create procedures that are much more flexible and that better use resources because of how you've coded them. And it does take a little bit more time to kind of get familiar with what I mean and how to do this, but it's not hard. It's just not intuitive. And it's not something that most people would do inherently. So once you see this and once you start to get a feel for this, I think it's going to make perfect sense. But until you see this, some of the behaviors that a lot of you are seeing on your servers are wildly varying, and they're hard to troubleshoot. And sometimes the performance is good, sometimes the performance is mediocre, sometimes the performance is terrible. And what inevitably happens in a lot of environments when you have stored procedure problems is people will do things like they'll look at the plan, they'll see the estimates are off from actual, and they'll do the knee-jerk reaction kinds of, fixes like updating stats, and then they see that the plan is better and they're like, see, it was those stupid statistics. And what's interesting is that you'll find a lot of the things that you do in SQL Server have side effects that might include what we call plan invalidation. And when a plan gets invalidated, then the next execution will get a new plan. So if you're currently executing a plan that's not good for your parameters, and that plan gets thrown out, and then you execute and you get a plan that is good for your parameters, you think problem solved. And if the thing that caused that plan to get invalidated was updating stats, then you have this kind of false positive where you end up thinking every time you have problems, updating stats might be a solution. And of course, you update stats and you get a false positive. So you keep thinking that updating statistics is the right solution when in fact it's not. So I love this discussion. And that was kind of just an intro because I'm sure that almost all of you, because I've never been to a customer that didn't have this problem, I'm sure that everyone has this problem, but being able to recognize that the problem is in fact parameter sensitivity and caching and how SQL Server works is really important. And I've got a way, I think a pretty cool way, for you to be able to recognize it even early on during development. So like I said, I want to focus on the demo, but I've got a lot of hidden slides in the slide deck. So I'm just going to hit some of the highlights and focus on the demo. So this is one of my favorite kind of easy pictures into stored procedure processing and creation. When you guys create a stored procedure, really not much happens. All SQL Server does is look at the syntax, and if the syntax looks good, if the objects resolve, then they will put the information into the metadata cache, which is essentially, or into the metadata, which is in the cache, yes, but it's also saved on disk. But it is just the definition of the procedure. It's not the plan. It's not any information about the procedure. It's literally just, this is the code. Now, there are some interesting things. If you've got a stored procedure that references temporary objects, they actually defer the resolution until execution because those objects may not exist until runtime. So resolution only really fully happens if all of the objects can be resolved. Now, at runtime, what SQL Server first checks is there a plan already in the cache that is appropriate for me? So if, of course, your server's been restarted or somebody's cleared the cache, and there's a ton of different reasons why procedures can fall out of the cache. So if there isn't a plan already in the cache that is available for you and makes sense for you, and that's another tangent. I don't know how much I want to go into that here, but there's also session settings. If you weren't aware, when you connect to SQL Server, certain session settings are set in a certain way. And those session settings also, at least certain session settings, have to be the same in order for you to use a plan that's in cache. So if user 1 has one set of session settings and user 2 has different session settings, even though the plan went into cache for user 1 and you think, ooh, that plan's in cache, so I should be able to reuse it. If you have different session settings, then there isn't a valid plan in the cache for you, so a new plan will get created. So that's kind of what I mean by when you execute and there is not already a plan in the cache that's suitable for you, okay? So, and some of you might not even know that SQL Server can have 5, 6, 7 plans in the cache for one stored procedure that vary based on things like session settings. They could also be based on resource governor groups, because you can clear a resource governor pool from the cache, or the plans from a resource governor pool from the cache. So all the plans per pool are stored. So if you've got 2 people in 2 resource governor pools, then there could be 2 plans in the cache. So it turns out that you can actually have a lot of plans for a stored procedure in cache. But if you are in the same resource governor pool, if you do have the same session settings, and some of you that have like one application that connects to SQL Server with thousands of users will end up having the same session settings. And as a result, you might end up only having one plan in cache that all of those users use. The key point is, well, really, the key point is it good or is it not good, right? That's what we have to kind of address. If we execute and there is a plan already in the cache, should we reuse it? And that's what I'm going to show you. So when you create a stored procedure, like I said, not much happens. Information goes into essentially the system tables. That is, this procedure does this, this, and this, but no plan gets saved to disk, right? On execution, a plan will go in cache, and that plan will get reused by other users if they meet all of those criteria. But here's the real clincher to everything. If there isn't a plan in the cache at the time that you execute, then SQL Server looks at the parameters you're passing in at that time, and it sniffs them or it evaluates them. And by evaluating those specific parameters, they will then optimize for those parameters and come up with a plan for those parameters. That is the plan that goes in the cache and is used by subsequent users. If subsequent users execute very similar parameters that would benefit from that plan, that's great. But there are cases when that's not the case. So let me give you a little bit of a summary on this, right? Procedure caching, or at least SQL Server caching those plans for procedures, a lot of people say is the reason to use stored procedures. To be honest, I disagree. I think there's a ton of other reasons to use stored procedures, and caching is not the number one of them, in my opinion. There's centralized logic, there's the reuse factor that you can use that stored procedure across many applications. There's the fact that, generally speaking, database procedures are created by hopefully database developers that know more about the data and how the database works, and they can create more effective procedures, especially with some of the things I'm going to show you today. So if you have well-defined procedures that are centrally located and more secure, that's a great thing, right, to use across multiple applications. So for me, that's the reason to use stored procedures. And if they're well written, then when the plans are saved, reusing those plans is fantastic. SQL Server will save time in compilation, and when really good, stable plans are saved, everybody benefits. The problem is that when stored procedures are not written by someone that knows the database, or really even just someone that doesn't know a lot about how SQL Server does caching, which, you know, I have to admit is not necessarily intuitive, right? A lot of people, developers aren't dumb. That's not what I'm saying. What I'm saying is you come to SQL Server and you have certain expectations and certain beliefs that, you know, caching is a great thing. And to a certain extent it is. But as you start to see that that stored procedure is used across, you know, 700 different combinations of parameters, then you start realizing that one plan might not fit all of those different parameters and combinations. And that's where reusing plans can actually be incredibly bad. And in fact, this is why some of you have found the little hint that you can put onto the statements of the stored procedure, option recompile, to be incredibly effective for you. And it is. And I like using option recompile. I'm actually going to show you that as a solution, but I consider it more of a temporary solution, and I'll explain why. So this is the good thing. I'm really going to spend most of my time in this session demoing. So let me get right to it. And I actually have a blog post on this as well. And sometimes I like to show that. So as I'm talking about this, I'm going to bring up on another, here, let me pull this to another window while I'm lecturing, and I'll set this up. But a lot of you probably have what I call an OSFA procedure or a multi-purpose procedure. OSFA meaning one size fits all, or multi-purpose procedure. And I think of it more like this. I've got a little picture where sometimes developers decide to be really clever and they create like a very generic dialogue that says, you want to look up a customer? Well, we're going to let you put in anything you want. You can put in a customer number, you can put in a last name, a first name, you can even put in partial wildcard last names, right? So you could put in TRI% or customer first name, KIM%, middle initial, right? Email address, region, customer type. And to be honest, this is kind of, I mean, it's flexible, yes, and that's maybe the good side of things. The bad side of things, though, is this can make for sloppy users as well. You know, I mean, you think of it as a cool thing from a development perspective that you're being really flexible and you're allowing them every single option that they could ever want to put in there, right? And you think that this is great, but at the same time, if the users that are using this app can just type in last name T, first name K, search, and then just scroll down and select their name, they might end up starting to get really lazy, or they might not ask the customer for the customer number, like if they're on the phone or something like that. Sometimes what I really recommend, instead of these very generic OSFA one size fits all dialogues, is to have like two levels of dialogue, right? And have one dialogue which basically is kind of the entry point, which has, do you know the customer number or the customer's full first name and last name? And then maybe at the bottom of the dialogue have something like more intense searching, or you don't have an exact match. I mean, if you're on the phone with the customer and they don't know their customer number, they pretty much should know their last name and their first name and how to spell them without any wildcards, right? And I mean, I'm joking, but at the same time, the more that you focus the users on more efficient searches and matches, the more efficient you're going to make SQL Server and the requests. I'm not saying never do wildcard searching and things like that, but if you give the dialogue to the customers or the users or the phone support folks like this, they might get sloppy, and in and of itself, that's going to slow down your server. So I'm not a big fan of this kind of dialogue, but even worse, right? What often happens is we create these dialogues and then we create, one stored procedure. Here, I'll make this a little bit bigger. One stored procedure here, I'll start it in sections. One stored procedure that has like all these parameters, right? We have a customer ID, whoops, ooh, I never knew it did that. There we go. We have a customer ID. If you double click, I guess it goes into a cut and paste mode and it changes the formatting there. But customer ID is one of the parameters. Last name is a parameter. First name is a parameter. So this looks fine. I mean, there's nothing that scary about this. But then there's, select from the table where customer ID is the customer ID parameter or the customer ID is null. Last name is like the last name or the last name parameter is null. First name like the first name or the first name is null. This is the part that is incredibly problematic and will cause you a lot of grief on the server. And it's not just this code. I mean, this is how all stored procedures work. What happens is when that stored procedure gets executed, whatever parameters come in, and let's say it's just the last name and first name, then the procedure gets optimized with the specific parameters that have been passed in, last name and first name. And SQL Server then decides, okay, how can I optimally find this information using a last name and a first name? And maybe there's indexes, maybe there isn't, but whatever the best way to get to this information based on those parameters is, SQL Server takes that and puts that plan in cache, and the next user comes in and they'll get that plan. Well, what if the next user coming in specifies an email address and the plan says use an index on last name and first name? Well, we're not going to be able to efficiently find that email address based on last name and first name. And what ends up happening is SQL Server does a very, very inefficient plan. And I'm going to prove this. So this is going to be the main focus of my demo. But I do have this blog post as well. So this might be something that some of you go to and read and review after the session, and maybe look at this in a little bit more detail too, if you're kind of a reader and want to see this code. But you will also get all of the demo scripts I'm doing today, so you'll be able to reproduce everything that I'm doing. And some of you might already know you have this problem, right? So you either have this type of a where clause, or maybe you're using coalesce, maybe you're using case expression. It actually doesn't matter. All of these are terrible. Okay, so let me dive in to my demo. Now, my demo is, let me pull it up here. Okay, so I have a sample database that I've been using forever, and I can still continue to use it. And I like using it because there's some things in the database that are they're terrible for real world environments, but they're great for teaching. Like I love really evenly distributed data to show and teach statistics, whereas in the real world, evenly distributed data is not very likely. So this database has some weird stuff in it specifically for teaching, but then it also has some normal stuff in it too. So I like this, and no matter what version of SQL Server you guys are on, I need to update some of my comments. But even if you're on 2017 or 2019, one of the early CTPs, you can actually restore the 2008 backup to any version 2008 and higher. So you can get my sample databases off of our SQL Server demos page. I don't put the sample databases in the zips, otherwise the zips would be monstrous and that one database would be duplicated hundreds of times. So that's just on our main SQL Server resources page. This is the one script you guys will have to change, because you'll have to point to where you've put the backup. You'll have to point to what server you want to restore to. In this case, I'm using 2016. I have 2017 on this machine as well, but it just, for simplicity, to me, the minimum version that I'm recommending these days is 2016 and higher. I know a lot of you are still using 2008 or 2008 R2, which, you know, if it ain't broke, don't fix it is maybe the mentality there, but that is going to go out of support this July. So you really need to be thinking about upgrading. And the coolest thing about what I just said is that you can backup restore from 2008 to 2017, which is so cool. It gives you an easy way, because you should be doing backups already, of restoring, testing, taking some time to see if there's any issues in 2017. And then when you're finally ready, you could even do, you know, close to high availability upgrades straight to 2017. I'm not really talking directly about that here, but I'm just saying I love this capability. So this is actually a 2008 backup that I'm going to restore straight to my SQL 2016 dev instance. So this is a named instance. And then I'm going to put the files on drive D. And this is the pathing that I'm going to use. And you'll see right here, I execute and it's going to restore and it kicks out the users. You can actually see that I do that in my code here with rollback after 5. And there we go. So it's kicked out all the users and restored my database. Now, what I'm going to give you for scripts is like this. I'm going to create a zip that has a bunch of little blog posts and links like that, and then has this multi-purpose procs SSMS SLN. If for whatever reason some of you guys aren't SSMS SLN users, you can just go straight into this multi-purpose procs directory and go to the restore credit, then the setup, then the multi-purpose proc, and you'll start seeing my different solutions and so forth. So We'll start with the setup script. So we restored credit. Now we're going to tweak credit to be a little bit closer to, whoops, I don't need to open it from there. I actually already have it open. So here it is. I reopened another window. So let's get out of that. There we go. So setup for multi-purpose procs. I had run this earlier, but I just restored credit as you saw. Now I say here first restore and set up the credit database, and now we're going to tweak a few things for this demo. I can just run this script personally because I know it works on my machine. One of the things that I like to discuss with people is how their developers are testing their code while they're developing it. Because how many of you guys have developers that have pretty decent machines, like my machine? I can get away with a lot of crappy code on this machine, and my machine just processes it because I've got 64 gig of RAM, I've got NVMe drives for drive C and D, drive E is a solid state drive, I've got 8 cores. I mean, I can really write terrible code, and my machine is just like, whatever, it just, I can do hundreds of thousands of IOs sub-second. And my point is, a lot of your developers can as well. So when they start testing their code on their machine in their development environment, my big question is, where did they get their sample data? Because often they just kind of pull it from various places. So here I say use credit. But then what I'm actually going to do is I'm actually going to say, well, I don't have a lot of data. So you know what? I'm going to take some data from AdventureWorks that looks similar, and I'm going to pull it over and do a little bit of tweaking to it so it's more like what I have in the credit database. And my point is a lot of your developers will do that. They'll grab data from here and data from there and data from here and data from there, and they come up with this hodgepodge of data that's not necessarily realistic, and they do their testing on that. And again, with their machine, things tend to look good because they don't have very much data and they have a decent machine. So you don't have to do this step. I'm just trying to prove the point that the way I'm going to show you to write and code and test, that's the most important part, is test the procedures. The way I'm going to show you how to test your procedures is that even with a decent machine and crappy data like I have, right, and not much data for that matter, I can still tell that this procedure has parameter sensitivity problems. And that's the coolest part about the type of testing that I like to do. I like to do code coverage testing, and that's kind of development 101. Every developer should be doing code coverage testing, but going further than that, I like to do something called plan stability testing, and that's what I'm going to show you. So we grab some data from AdventureWorks, and then there's a couple of other things. And I mentioned here, you do need to do the rest of these modifications. I'm going to add an email column to my table. I'm going to give all employees a middle initial. I'm going to add a couple of rows, one for me, one for Paul. I'm going to give all my employees an email address. And at the very end there, I'm just going to get a quick count. I have about 30,000 rows. And some developers will be like, yeah, 30,000 is a pretty good number for me to test against. But if I start to show you the data, so here I'm saying, give me top 100, top 1,000, order by last name, and I'm just grabbing some rows, and you start to look at them, and these look pretty good. Jamie Allen, there's the address and all this stuff, right? So some of these are starting to look pretty good. And then you get to some of these, and you're like, ugh, these don't look great. Like this looks randomly generated, and look at how many repeats of bar there are. And wait a minute, these are all uppercase, whereas these are mixed case. And my database is, and most servers are not case sensitive by default. So we're probably okay with this, but some of you might want to do case sensitive searching and things like that. So the point is, this is ugly data. And it's not really great. There's weird patterns to it and all that. And that's very realistic. Okay. I mean, realistic of test environments. It's hopefully not realistic of production, although sometimes that's the case as well. And so I make a few notes in here. Names are everything from goofy to realistic. And the searches are across all of these different columns, right? And the other thing that I see really commonly in development is kind of where clause index, where clause index. If we're going to do a lot of searches by first name, well, we should have an index on first name. And I kind of agree with that, right? If we're going to do a lot of searches on last names, we should put an index on last name. If we're going to do a lot of searches by email, we should have an index on email, right? And if we're going to do a lot of searches by member code, we should put an index on member code. And this is kind of a big it depends, okay? Narrow indexes like I've just created here. So narrow meaning very few columns in the definition of the index. Narrow indexes have very few uses. And what that means is even though they do have some uses, and even though there are cases where they are incredibly useful, the number of uses that they have is pretty limited. And there are cases where they're useless, okay? Especially with something like member code. If we start to look at member codes, there are not very many member codes. So finding a case where using the index on member code is a good thing is pretty limited. So my point is sometimes this whole where clause index, where clause index, where clause index that results in a whole bunch of narrow non-clustered indexes is actually not ideal either. But this is very common. So this is kind of my setup, right? We have a fairly typical environment, not that great of data, not that much data, a whole bunch of narrow non-clustered indexes for the columns that we're likely to do searches on, and then we have an OSFA procedure. So these are just my comments, kind of like the slide where I was talking about, column variable or variable is null, right? We're going to use credit, and if it exists, I'm going to drop that procedure, and here's that code. We're going to create the procedure, last name, first name, middle initial, and then there's our query that looks for that information based on the parameters being passed in, unless that particular parameter is null, right? So we'll say create that procedure, and then as a developer, right, code coverage testing would say, do a bunch of executions. Now, it really should say do a lot more than what I'm doing here, but let's just say this is kind of a quick initial test. So I'm gonna run it for Tripp, and I get back my row. It came back really quickly, which by the way, I have the numbers here at the top, just because I thought that might be easier for some of you to see than at the bottom. So if you're looking at the bottom for that, I put it at the top, okay? So query executed successfully, and sub-second. So then we come over here and we do like this %27.com, and there's a bunch of rows, but 1,000 rows, but look at that, that came back sub-second as well. And then we run it, 9912, that came back sub-second. I mean, a lot of developers would be like, well, okay, it worked. Now, of course, if they're really doing code coverage testing, they should have a lot more testing than this. And I'm going to come back to this in just a second. But what a lot of people would say at this point is like, it works. I'm getting the right data. It's running really quickly. Hopefully they'll do more testing than this. But ultimately on this machine, if they see good performance and it runs really quickly, they're going to end up saying, we're done, ship it, right? Now, I prefer to have, if I'm developing a procedure, I will often have a testing procedure or a testing script along with that procedure over here. Okay, and I might have different scenarios, get member information, member number 9912, get member information, Tripp Kimberly. Whoops, I just moved that. There we go. I might have an email. I might have some combination. I might have a member number. So I might have a whole bunch of different tests. Okay, so this would be better, right? If I really could do testing across a whole bunch of different combinations. And this might be a script that I save so that if I ever make any change to my stored procedure, I come back to my code coverage test, right? So this would be a better way of doing things. And I'm going to show you guys a little bit more on why this script is so cool in a second, okay? What I like to do, though, is to take this code coverage testing concept a little bit further. And I like to do what I call plan stability testing. And I'm going to ask your developers to start looking at plans, but they're not going to have to know all of the ins and outs of SQL Server plans. This is the good news. You can actually determine that you have plan stability problems without really fully understanding all aspects of that plan. That's the good news. So there's actually some really cool things, if you know to look for them, that will help you to understand that these procedures are prone to all sorts of problems. Right now, the developer thinks it works fast, it runs, it looks good, hey, ship it, okay? Instead, I would say turn graphical show plan on, right? Plus, we'll at least turn IOs on. Time, on a machine that's pretty decent, the times might be so darn close that time is not really showing me much. But if I look at IOs, you might see some pretty radical differences in the IOs. So I just turned the graphical show plan up here, okay, include actual execution plan, and then I'll try these same executions again, execute. Okay, so now it takes a little bit longer when you turn on the execution plan, but really it did, again, come back pretty quickly. And if I go look at just the execution plan initially, and by the way, I am using version 18 preview 6. I don't know if another preview's come out. I know this one came out about a month ago. But my point is my show plan might look a little different than yours. One of the things that I've noticed in these later previews is that it looks a little bit more crowded on the show plan, but it actually does give you a little bit of insight into what I'm discussing even here. So I'm going to describe this for everyone because some of you might not be using this management studio. The first thing that a lot of you guys might see is the 33, 33, 33, right? That's across all three of the different batches. And that implies that the cost to execute this query is pretty much even across all three of these executions. And that is true because of how SQL Server calculates that query cost. That query cost is coming from the plan in cache. Well, the plan is the same for all of these, so the expected cost to execute it is the same. Now, is it actually the same? Now, if you're not in the new management studio, probably the quickest way to tell is to go over to the messages window and look at the IOs for a second. And I don't know about you, but that does not look even, right? The first one has 78 IOs, the second one has 90,063, and the third one has 78. Okay, the first one and the third one, yeah, they seem like they're about the same. But that middle one seems like it's way off. If I go back over here in the execution plan, 33, 33, 33 doesn't seem to tell me much. However, if you do read the new thing they're showing, they say one of two 50%, but down here it says, and I think they might be able to display this a little bit better, but see how it says 29,996 of two, and then this ridiculous percentage? That's kind of telling you that they expected two, but they got 29,996. So this one is way off, okay? Even though the cost 62, 62, 62 is the same, this one actually cost them more because that 62% cost was based on the two, not the 29,996, which is why over here the IOs are so darn high and why the 33, 33, 33 doesn't actually match. Now at this point, developers might not notice this. Okay, I mean, they might notice it if they do the statistics IO and they look across the plans, right? To be honest, if I start showing you the plans themselves, like, let's just talk about this for a second. The first one that I executed was get member info last name Tripp. And remember, I updated one I updated one row to be Kimberly Tripp, and I promise you there's no other rows with a last name of Tripp. In fact, let's just execute that one again, and I'll show you that there's only one row. If I go to that plan, before I even show you that plan, if some of you think about this, if there's a non-clustered index on last name, we should just go to that non-clustered index on last name, find Tripp, and then go look up the rest of the data for the row because the query is select star. And we go to look at the plan and it says an index scan. of the non-clustered index member last name. If you look down towards the bottom, it says object credit DBO member last name. And if you look at the top of that yellow tooltip, it says index scan, scanning a non-clustered index. Well, it says scan a non-clustered, but it is literally doing an index scan, not an index seek on the last name of Tripp. And why is it doing that? This is another side effect of this OSPA style procedure, that as soon as the multi-purpose procedure, wait, where is it? Oh, it's in the script that we're in. As soon as the multi-purpose procedure has like, then you start seeing scans instead of seeks. And this is terrible for most executions. It's even terrible for like the Tripp execution that could have done a seek. So my point is, this is really not a great plan for any of these, even the Tripp case. So if you're starting to suspect that you have plan problems, or even from a troubleshooting perspective, one of the cool things you can do is you can execute the procedure and then execute the procedure with recompile kind of side by side. Now we know that this one, which is doing currently 90,000 IOs, we know something is wrong with that, or we know that that's not as optimal as the other executions, at least. So you can basically say here, line 142 uses the existing plan from cache, and line 145 says, give me, line 145, my own plan. Don't look at the plan in cache, don't touch the plan in cache, and don't put this plan in cache, and this plan will never get reused. It's literally just a plan for that execution. And what's cool is when you compare these side by side, I mean, you can almost immediately tell that something's different because I got the data back in a different way, which is irrelevant because I don't have an order by, right? But if I just go look at the execution plan, even if you don't know anything about execution plans, my joke is get your 5-year-old involved and say, honey, does this plan shape match? You know, do these patterns look the same? That's literally all you're really looking for, is the plan where we recompiled the second one, where we told SQL Server to get an optimal plan just for this execution, is it the same as the first one, which is use the plan in cache? And obviously the shape is different, so the answer is no, they're not the same. So that tells me that the optimal plan that I get for 145, right, or the optimal plan for this stored procedure will need to vary based on the parameters I'm passing in. Now, I'm just starting this discussion, really, okay? So I'm starting to sense that my procedure has parameter sensitivity. I can do this for this next one. This one's a little bit harder, though. I run it for 9912 and 9912 with recompile, and then I look at these two plans, and they actually do have the same shape. This one's a little bit harder to see and to get some insight into. Interestingly, 5743. So they have different percentages, and they have slightly different IOs, okay, a little bit less, fewer IOs in the second execution. This one's harder to see because it's not as drastic and it's not that big of a difference, but it did use a different index. So it resulted in a little bit less work and fewer IOs. So kind of my point is this one's a little bit harder to see, but if you did have a nice code coverage script, right, what you could start doing is this, and this is kind of interesting. I can use credit, right, grab the date and time, turn the IOs on. We're not going to turn on show plan or anything like that. In fact, I can just do that, okay? And then here's kind of the cool thing. I can do an SP recompile, okay? Go up here and recompile. Now that gets rid of essentially the plan from cache. It really doesn't. It does something called invalidation, but essentially the next execution will get its own plan. And since I'm the only one on this machine, I'm the only one controlling that, right? If you're on a production server, who knows who's going to get there next, okay? But what's cool is I can go down and pick a test scenario, like test scenario 3. And I could pretend that, let's say, this is the scenario that gets executed first. And when I do that, that's what's going to put that plan in cache. Then notice that the recompile is commented out. So what that means now is when I run this script, all of these test scenarios are going to run with the plan that they're getting from scenario 3. And even, I mean, time, in fact, I'm going to turn time off because on my machine, time's just not that exciting because everything's running pretty darn quickly. And I don't have show plan on right now. So let's just look at IOs, okay, for right now. And, you know, you can play around with that if you want. Turn that on, turn that off. But I'm going to just have IOs on and I'm going to run the whole script, okay? And I'm getting my results. And when it's all done, I kind of have a starting time and a stopping time. So I could track the time and then I could go over here and look at the IOs. I always have the queries go to the output window as well. But look at this, 292, 90,000, 292, 37,000, 292, 292, 3,000, 90,000. Well, first of all, that doesn't seem very consistent. Now, some of you might be saying, well, they're different plans, there's different number of rows coming back, so I would expect some inconsistencies. Okay, I agree with you, okay? But I wouldn't expect significant inconsistencies just because of the plan changes, right? So 292, 90,000, 292. I'm gonna go back over here and I'm gonna invalidate that plan, okay? Again, and now I'm gonna pick a different scenario. Like let's pick scenario 4. Just, you know, we pick scenario 4 and then we'll come back and run the whole thing again. Okay, I happen to know that scenario 4 is kind of yucky. And I come back over here and I look and there's a few things that have changed, right? I'm not just seeing IOs, I'm actually seeing work file, work table, work file, work table, work file, work table. And I'm seeing different, remember before it was like 292, 90,000, 292? Now we're at 90,000 for scenario 3. And one of the things you can start to do by looking at the stability across plans is you can start to see how inconsistent some of the executions are. Let me go back to the slides and pull this together. I still have a little bit more that I want to demo. I just want to try to keep us on track as well. So remember, I'm trying to create this multi-purpose OSFA procedure. And I started out by showing you they might look good in development, but ultimately they do not scale in production, right? And when I did my demo, I showed you that, you know, development machines wildly vary. The data size and data quality absolutely does matter, right? The more accurate the data, the more accurate the environment, the better off they're going to be from a testing and a tuning perspective. It's just that's not the real world, right? Developers have really beefy machines, relatively speaking, and not all that much data when they're doing development. So they don't see some of these problems early enough. And they end up seeing, you know, hey, it looks good, it looks good, it looks good, ship it. And so when it does get into production, you start to have lots of problems because there's more data, there's more users, there's wild patterns of executions, and unfortunately, then, you know, the proverbial stuff hits the fan. So one of the things I like doing is this plan stability testing. And this is what I really love to do. Okay, now some of my numbers are a little bit off from what I showed you because sometimes my environment is different and so forth, but it's pretty close to what we saw. And what I often will do is take my code coverage tests and track the different plans across the code coverage tests just for IOs, okay? Because I should get, if I'm getting the same plan, the same IOs for the same parameters over and over and over again. So my argument is that if I have really stable plans, no matter what parameters I execute, test one should have the same IOs all the way across, and yet it doesn't. So this screen results from me doing exactly what I just showed you. I take that code coverage script, I recompile, okay? And then I say, okay, let's put scenario 1 in the cache, okay? Go. And then I run the whole script and I track the IOs. So I come over here and I see 50, 90,035, 90,035, 3152. In fact, these might match perfectly. So there you go. 50,000, 9035, 9035, 3152. So I start to track what that particular plan, when it's in cache, does to all of the other scenarios. And sometimes it's okay, sometimes it's not okay. And then I say, okay, go back over here, kick that out, right? SP recompile, and I go and I run scenario 2, execute, that puts that plan in the cache, and then I see how it impacts the other plans again. And right now you could look just at IOs, right? 78, 78, 90,000. So I come back over here, 78, 78, 90,000. So my point is you start to see, well, scenario 2 is great for scenario 2, right? It's certainly better than when we had scenario 1 and its plan being used for scenario 2. And the point is, as soon as you start to see these wild variations across the different executions, then what you know is that you have plan instability. The plan, the optimal plan, will vary or will need to vary if you want the optimal plan across some of the different parameters. Okay, so this is pretty easy, I think, to recognize, especially if you're looking. Okay, if you're looking for it, it becomes really obvious. It's just most people do code coverage without spending a lot of time like looking at the plans or looking at the IOs. And like I said, you don't even have to know everything that's going on with those plans. You just have to look. You just have to look to see if they're different or if there's wild variations in the IOs. And I even put a little bit more here for test 4, because if you end up looking at the show plan as well, those work tables and work files that you saw, that was because the plan is doing a hash match join. And what ends up happening is that on first execution, they estimate how much memory they need for that. And when they actually execute some of the scenarios, there's not enough memory allocated. It's called the memory grant. And that memory grant's not high enough. So then they have to spill, blah, blah, blah. I'm tracking more than even you need to track here. You could actually just put the IOs and then put other stuff as well, like just a little note that there was more that you saw in the results with statistics IO. Maybe you didn't know what they meant, but again, you're just seeing differences and you're seeing that there is in fact some kind of problem. So now here's where we're at. And I would really recommend playing around with that little multi-purpose procedure execution script that I have and using that as a pattern and get your developers into a pattern to do that kind of a script for code coverage testing, but then go back later and do what I just did, which is create a little diagram of how the different plans affect the different test scenarios. And that will start to give you some insight into whether or not you have wild problems in plan stability. Now, if that's the case, some people might see this on almost every one of their stored procedures and start freaking out, right? Like, oh my God, this is everywhere. What do I do? And it might be. Now, I am not going to recommend that you execute everything with recompile. In fact, to take that a little bit further, execute with recompile is not ideal anyway. So I really only recommend that for testing, okay? There's a bunch of issues like when you execute with recompile, it doesn't go in dmexec procedure stats or dmexec query stats, so it's a little bit harder to track and troubleshoot, okay? Now, you could do an SP recompile and kick the plan out of cache, hoping that you are the next execution and that your execution is a more common combination of parameters so that subsequent users will benefit. But what if you don't get there first, right? So there's no guarantee of this, right? That really only fixes whoever gets there first, which might not be you, after that recompile. So that's not a great fix at all. Updating stats, even though that might appear to work, right? It doesn't. The side effect of updating stats is that they do plan invalidation. And it's really the plan invalidation, which you could have done a lot more quickly and easily with an SP recompile. That's probably what fixed it, not the updating of stats. And now, not only have you spent all this time updating stats, but if you didn't update stats during business hours, you may have used sampling, and those sampled stats may be less accurate than the stats that were there, because the stats that were there were updated off hours last night with full scan. So do not update statistics in the middle of the day unless you're positive that that is a beneficial thing to do. It's not a knee-jerk reaction type of thing to do, especially with a procedure problem. Okay, I'm not saying statistics are perfect. They're far from it, but they get blamed a lot when it's not their fault. More often, it's a plan problem, not a stats problem. And then there's option recompile. A lot of you have probably heard about this, and a lot of you have probably used this, and I have no problem with this. The problem that I have is that it's getting used a lot. And the problem is recompiling for every execution all the time is not necessarily needed for a lot of you. And I know a lot of you have heard this, but that is, in my opinion, a great interim solution. It's a great quick fix. It is something I would do in production to fix this problem, but it's not my long-term solution. Okay, so let me show you this fix. I started at about 10 after. My 60 minutes, I'll probably go till about 10 after, and then I'll stay for more questions. But let me show you this quick fix. So solution one is the super easy, super quick fix. So I'm going to turn statistics IO on in this window. I'm going to go ahead and literally just add an option recompile into this procedure. I mean, you got to love the simplicity of it. I'm going to run a couple of executions, and all I'm looking at again is IOs. And wow, 5. We never saw a single digit number, right? 926, 3. Like, we look at this and we're like, this is crazy. This is fantastic. And often the cost of compilation is far lower than the execution of, especially if it's a really bad plan, right? So very, very cool. Like, we might think this is great. In fact, we might go over to our code coverage script and we might just run that whole thing and see what the IOs are across all the executions, right? And check this out: 3, 5, 6, 400, 3, 6, 9. I mean, this is incredible, actually. Like, we don't see anything of the 90,000, right? So I know you're all looking at this and you're like, is she kidding me? I am going to use this, right? And I say it does work great in development, like my environment that I just showed you. And it does work great in production, but only to a point. It gets abused a lot. And unfortunately, I'm starting to see more and more that people are starting to run out of CPU. But I have to tell you, if you look across all the executions and all the different scenarios, we never saw numbers like this, right? If we compare this to that other slide, I mean, most people end up wanting to just run out of the room and change all of your code, right? And get off the webcast and start fixing things now. But just give me my couple more minutes to wrap up, and I will show you why I have a better option. And in fact, before I even show you that better option, let me give you a concept, right? Not all of your procedures have, 7 or 8 parameters. And in fact, for simplicity, I'm going to pretend that, let's say we just have 3. You can pass in a member number, a first name, a last name. You could, if you wanted, just say, I want to find all the people that have a Q in their first name, right? And you might think, that's pretty selective, but if you do it like that, there's really no good efficient way to find that data. And my point is, with only 3 parameters, right, they could pass in one of them and just one of them. They could pass in two of them, right? Member number and first name, member number and last name, first name and last name, right? Or they could pass in all three, member number, first name, and last name, right? So you get my point. There's 3 parameters, 7 possible combinations. If you were to go to a data set, and the query was, select all the people from this community where there's a Q in their first name and member number equals 1, 2, 3, 4, 5. It would be really easy. All of you would end up saying, I'd go look at member number, and who cares about the first name? I'd filter and check the first name after I found member number 1, 2, 3, 4, 5. And my point is, depending on how these parameters are being used, it turns out that there are scenarios that would in fact generate a stable plan. And in fact, anytime the member number is supplied, it would be a stable plan, right? Because these are being ANDed together. So you could argue that even though the option recompile fixed where there were problems across all of my different scenarios, in the real world, maybe you've even got a 2-level dialogue and you've started to teach the users to know the member number going in. So the more likely execution is that they have the member number. So instead of like member number alone being, 1/7 of the possible combinations, maybe this is, 60% of the executions are asking for member number. That would mean that 60% of the time, at least 60% of the time, you don't need to recompile. And by just shoving option recompile into all your code all over the place, you're going to waste CPU, and you're going to force SQL Server to be generating over and over and over and over and over the same plan that it could have cached and leveraged. So here's where I get to my more complicated, yes, but incredibly effective solution. And this is the one that'll take your developers a little bit of time to get comfortable with. But ultimately, what I like to do, and it's a longer set of code, but what I like to do, and I've got lots of comments in here, I have my parameters, and I, have error handling and stuff. And I guess I should do more try catches and stuff like that. The only thing I'm really checking for here is that they're supplying at least one parameter, right? So that's the first part of it. Then notice here, I'm creating a string that I'm going to build. And that string is going to basically include all of the parameters that they've supplied, but only the parameters they've supplied. So when member number is not null, then I'm going to add on to the string, and member number is the member number that I'm passing in. If the last name is not null, I add on the last name. This is a pretty simple pattern. Now, obviously, some of your code might be more complicated than this, and you might do the branching and logic differently, but here's the real trick, okay? You build the string with whatever the non-null parameters are, and you decide whether or not you're going to recompile. And right now, notice my recompilation flag, it's a bit calm, so it's just 0 or 1. Right now, it's 1, so it's on. I'm basically going to recompile. So then I build my string, and I have some logic in the string, which could be just this to start with. It could be just this one little, conditional statement. If the member number is not null, then we're not going to recompile. And that could be it, right? So if they supply a member number, don't recompile. But you could also get more, clever than that, right? If the pattern of last name before and after the wildcard is at least 4 characters, or I should say, the wildcard is at the 4th position or later, for both the last name and the first name, or there's no wildcard, then we're not going to recompile. Meaning the last name is like TRI% and first name KIM%. Maybe that's selective enough that we know we can use indexes, so we're not going to recompile for those cases, right? So there could be, you could say if the email is at least, 9 characters preceding the wildcard, or 10 characters, or 20 characters, or whatever. So this is where, and this is something you could modify over time. This is where you can set kind of when you recompile and when you don't, and then how do you recompile recompile? Well, if you're supposed to recompile, then and only then do you add option recompile to the string. Now I've got the select just so you can see the result of what I'm doing. This you'd comment out. And then here's how I actually execute it. I'm using SP execute SQL because SP execute SQL forces the statement to go into cache with its plan and reuse that plan. So this actually behaves just like what we want, except when we pass in option recompile. This will take you some time to get used to. Don't get me wrong. It's a little bit longer. It's a little bit uglier. It seems more complicated. And I know some of you have, 20,000 stored procedures. I'm not saying to go alphabetically through your stored procedures, changing them to be this code. I'm sure at least 3/4 of you probably can name your most problematic stored procedures because they're almost like swear words on your team. That get member information procedure again. You're kind of losing your mind with that procedure, right? So some of you know your culprits to look at and to evaluate. So you could even, if you wanted, just have a conditional logic kind of way of doing this, like if member number is not null, execute the statement with option recompile, otherwise execute the statement without the option recompile. I mean, you could do that. I would do this that I've shown you, but ultimately you can even do it a little bit more simply. So now let me go back to my multi-purpose procedures and I start to run through this again. And we will start to see, oh, I've got more output this time. I want you to see that too. Remember, I'm also outputting the statement, select from member where, and the 1 = 1 is just a dummy where clause, and member number is the member number. But notice there's nothing else. And then this next one had last name and first name, and it had a full last name and first name with no wildcards. So notice there's no option recompile in the statement. And then the next one had a full email, so there's no recompile. But then this next one had, I think it has a few things. It has a member code and a region number, and this one has an option recompile in it. So this plan won't be saved for anyone else to use. And you end up starting to see the really good IO numbers, and across the different patterns, you would get a new plan for the things that need to wildly vary. So that is my better way, much better, incredibly better. So you can get huge benefits by switching to option recompile, yes, okay, but be careful. If that becomes the new hammer to your problems and you try to fix every problem by shoving in an option recompile everywhere, I promise ultimately your servers won't scale, and then you'll have to go back and start figuring out what to modify and so forth. You will really get a lot better. Like if some of you are administrators or operators dealing with the problems, go ahead and put the option recompiles in as a fix, but immediately turn around, get with the developers of that code and at least point them to this content and have them get some insight into how they can more programmatically define when to recompile instead of just recompiling everywhere, okay? And ultimately, this is what's going to happen. You'll cache your stable plans, which is obviously going to save time and CPU. And the unstable plans are going to get recompiled, yes, but you're only going to add the extra CPU where it's really needed. And often recompiling is way better than executing a bad plan. So this is a really cool thing. And there are some cases where, workload specific patterns might mean that it doesn't get recompiled much at all. So it can be a huge win for some of you. So I love this scenario. I love this demo. I love this lecture. That was only an hour on this. I have a lot more content out there. I've got a bunch of resource slides at the end of this, more blog posts, obviously the one I just showed you, the building high performance stored procedures. I did do a past presentation in 2014 that was on Past TV. I'm not sure if it's still available because it's a little bit dated, but you might be able to watch that. Pluralsight, if you ask Paul for a code, I've got that in the hidden slides. You can send him an email and say, hey, I don't have Pluralsight, so I have some stored procedure related courses on Pluralsight. There's more blog posts. Like I told you, I've got more plan cache posts. So like I said, there's tons of resources. I'm going to literally take everything I just did, bundle this all up, and send it back to Glenda and Steve and so forth, and they'll put this wherever they normally do with the DBA fundamentals resources. And you guys will be able to have access to this when the recording's available, which I know takes a little bit of time. I haven't seen any questions pop up in the chat window. I'm certainly more than welcome to do questions now. But outside of that, I usually say, thank you and have a nice life. And I hope I see you again at a conference or somewhere. And I hope you guys enjoyed that. And I guess I hope you're still there. No, I can see that there's attendees and now I can hear you. So I think you're still there.
Yes, and so in the questions panel, not the chat panel, but the questions panel.
Oh, darn it. I was watching the chat panel. Okay, sorry. Darn it. Most of my other WebEx and stuff does. Oh, a lot of people are saying thank you. That scared me because there's so much stuff in here. Oh, but this is awesome. Okay. If you let me. Oh, cool. I like some of the comments. Thank you, guys. Those are very nice comments. I'm just trying to widen this a little bit because I want to be able to read these better. Okay. Let me start at the top. Greetings, starting job myself. Please really learn more. I never attend. Okay, went quiet. Okay, is it safe to clear the procedure cache when tempdb is getting full? Does tempdb store the execution plans? They're totally orthogonal. So tempdb getting full is irrelevant to a database's plan cache. But it is true that SQL Server will steal from the buffer pool to give plan cache resources if the plan cache has not reached its maximums. So that's a really interesting question. I would really say that they're not related, but I suppose if tempdb is really starting to eat up your cache, procedure cache would still always be deemed a higher priority. But you're saying, is it safe to clear the procedure cache when tempdb is getting full? Well, okay, tempdb doesn't store the plans, so I'll start with that. So no, tempdb doesn't store the execution plans. And is it safe to clear the procedure cache when tempdb is getting full? They're just not related. It's kind of like, should I eat an apple when I want an orange? Well, I don't know. You can clear the procedure cache. I would probably argue that I would maybe look more at why tempdb is getting full, because I might be able to change some code, add some indexes. Like tempdb is the work area for SQL Server. So if what's going into tempdb is a lot of hash aggregates and things like that, I might be able to put an index onto a structure and eliminate all those work tables from tempdb. Because if you have a hash aggregate going into tempdb, you actually have that work table going in for every user querying it. If you had a different index that could support what that hash aggregate was doing, they would all use that one index and there would be no work tables in tempdb. So there are some cases where how you're using tempdb and changing your behavior to tempdb would be better. But Shree, if you want to put some more in another question at the bottom, I'll come back to you. Do you advise for a procedure that does dynamic sorting, different columns, not all are indexed, and dynamic sort order? Oh, hey, Rob. Oh, he's left. Darn it. Well, at least I'll put this into the answers. It's a great question. Maybe I'll send Rob an email. But if you have stored procedures that are doing a lot of different things dynamically, like dynamic sorts, first of all, building the string dynamically would at least put a different version of the statement in the cache for each combination. So that would absolutely be the first thing that I would do. Then I would figure out which of those things would need to be recompiled. So to be honest, the strategy that I showed you guys actually works really well almost no matter how dynamic or even what kind of different types of patterns your procedures have. Explain the different testing methods. I think I did that. That might have been before I actually started showing you that. Okay, priorities. Why is the query cost higher? I wish I had seen that at the time. Daniel, if you can remind me of where that was. Well, why is the query cost higher? That might have been where I executed the two that looked the same, and one was 57 and one was 43. And the reason the query cost was higher is that the second execution was in fact a more optimal execution. Even though the pattern looked the same, the index scan was smaller. So that's the only one I could think of, Daniel, but let me know if there's more to that. Okay. Oh, Stanislav, thank you. That was nice. If you execute a procedure with option recompile, do you cache a plan for each execution? If so, is there any meaningful amount of memory used for this cache? Okay, so this is an interesting question because you said if you execute a procedure with option recompile. Well, first of all, procedures, the only way you can do it is execute with recompile, not option recompile. And if you execute a procedure with recompile, you do not cache a plan for each execution. So there isn't any meaningful amount of memory that's used. Okay, so you don't have to worry about that. Now, if you execute a procedure where some of the lines of code have option recompile, then each execution essentially replaces the plan that was in cache for that statement. So you always have the last execution. Now, of course, Query Store comes into the mix as well in 2016 and higher. So that will allow you a larger history over which you can analyze different patterns and so forth. But the default behavior for option recompile, and the reason that I prefer much prefer option recompile than execute with recompile, is that the plans do go in cache, they do go in query execution stats, and they go into dmexec procedure stats as well, so you can start to see the plans and the patterns. And I do a whole bunch of demos in my Pluralsight course if you're super interested, Matt. Okay, test 13 had the same IO values across all queries. Is that an indicator of something? Ooh, it did? Are you sure? I'm going to go back to that slide just to look. Test 13. Oh, yeah. Okay. So test 13 had the same IO values across all queries. It's because it did a table scan, and the table scan can be used for virtually any request, and therefore it didn't have to change. And you might argue that some of you might want that plan because it's kind of the lesser of most of the evils across the plans, but I would still want something that was more dynamic. But yeah, good question. I don't think I even noticed that, but looking at that, yeah. What about using recompile for data warehouse workloads? Yeah, Alvaro, that's a good one. I'm not against using option recompile, and especially across, reporting workloads where there's wild variations in the requests and huge amounts of data. It's more likely that option recompile is going to be more desirable there. I mean, there's no doubt about it. But I would still argue that there might be some queries, some patterns that are stable. So I'm still a bigger fan of not putting it everywhere, but that is probably where you would have it more commonly within your stored procedures. Yeah, these principles apply for all sorts of procedures. In fact, yeah, whether they're nested, whether they're recursive. I mean, if the plans aren't stable, you generally don't want to keep those. And dynamic SQL. Oh, Michael, I wish he hadn't left. Hopefully he'll come back and listen to this. But dynamic SQL is interesting because if you mean exec, what's interesting about a statement that's executed with exec is that that statement becomes ad hoc, and ad hoc statements are very unlikely to be cached and reused. There's one exception, and that's when the statement's really what we call safe. But to be safe, it has to be really, really simple. You can't reference more than one table in the query, right? You can't have a like, you can't have an or, you can't have a subquery. So it turns out that when you put something into an exec string that has any complexity whatsoever, you're going to end up finding that it's going to get a new plan on every execution. It's almost exactly the same thing as doing option recompile. So there's not much of a difference between option recompile and making it completely dynamic using exec. So my hybrid that used SP-execute SQL will not recompile as often. It'll only recompile when I say option recompile. So that's the big difference between dynamic and SP-execute SQL. And I have a blog post that goes into a little bit more on that. So I can put that into the links as well. And it looks like, okay, there's a couple of thanks. You're welcome, guys. Thank you. Okay, some of my devs are fighting with each other. Yeah, that's pretty common. Over when to use views versus stored procedures. That's an interesting one. I mean, a view is just a tabular definition of data. I mean, it's just a data set. It doesn't store anything physically, and it doesn't have any logic per se. Oh, no parameters, some functions in the select, but nothing really complex. Is it 6 of one, half dozen of the other? Or is there really a difference? Oh, this is a great question. I mean, to a certain extent, one of the things that's nice about going through views is that SQL Server has to resolve that view and figure out what the base table requests are and optimize at runtime. So the plans aren't going to be saved, so you'd never have parameter sensitivity problems through views, okay? Whereas with a stored procedure, if you have a whole bunch of parameters, well, you say no parameters. So if there's no parameters, then that stored procedures plan is going to be saved, and you could make the argument that if there's no parameters and it's doing the same thing every time, that at least you'd save that plan and you wouldn't have to resolve it like a view. My problem though with views is that sometimes views are abused, like views on views on views, and then people start doing Cartesian products. So this is a tough one. I mean, you can do like I did and see if if there's no parameters, every execution would be the same. But I'm wondering what might be in the stored procedure. You said there's some functions. So if there's any function that like grabs date time, right? And or grabs something that's dynamic, like the username, or grabs a max amount of something, then the number of rows, if they wildly vary, then the plan might need to vary. The view would allow those variations, but the stored procedure wouldn't, because the stored procedure would have the plan. So, Stephen, that's a tough one. I mean, I would have to do a little bit of testing to see what the stored procedures did. But the stored procedure might be the better way to go when things are stable, because you'd have that plan cached. But if there is anything that changes the behavior of the stored procedure, those might be better with a view, because then you'd get that flexibility. But I would also argue, if I wrote the stored procedure, I could create that flexibility. So I like the stored procedures. I think they're easier for the users too, because the user just has to say get blah blah blah, execute the procedure. Whereas with a view, they have to do a select, they have to do a where clause. And the other problem with views is sometimes the users end up using the views in ways that the people who wrote the views never expected, and that in and of itself creates problems. So stored procedures might lead to fewer problems. This is the type of discussion that hopefully someday I'll meet you at a bar and we can drink over this discussion, because there isn't a great answer to it, but it's a great philosophical one. Okay, so let me see. Let me see where I'm at here. I scrolled and I went the wrong way. I need this window to be bigger. Whoa, I just lost the window. Hold on. Sorry, I thought that maximized the window and it didn't. It minimized it. I'm trying to make this much bigger. Can you? You really just can't do much with this chat window or this questions window.
I know.
Okay. Okay. A bunch of thank you. Oh wait. How is option recompile different from with recompile? Well, I think I've answered that one. And Mark's left. Simply put, remember, option recompile is at the statement level. With recompile is at the procedure level. With recompile is not as good. It's not as flexible. It doesn't put the plan in cache, so it's hard to troubleshoot like long term, whereas option recompile is much, much better. So in the end, I use with recompile for testing. I use option recompile as a solution. Okay, and we got all those. We got all those. Ooh, I think I might have gotten them. Hold on, we're getting close. Okay. How do you address no join predicate in a nested loop in a plan? Wait, how do you address no join predicate in a nested loop in a plan? I mean, it sounds like you might have a Cartesian product. I'd like, David, if you can post any of the code or what that might look like. I don't know off the top of my head, but it might be that there's no other predicate to help that particular join. I don't know why it's doing a loop join though. Might be really small data sets. I don't know off the top of my head. Okay, good. Krista, you answered. Okay, good. Okay, if a primary or unique index, wait, disregard, and other, wait, if a primary key or unique index given, disregard, and other user specified search criteria. Oh, I see what you're saying. You were saying that to what I was saying, which was member number, which was the primary key, which was unique, and if they supplied that something that was primary or unique, so some type of identifier for the row, then you can basically keep the plan. Otherwise, go and recompile and use the other criteria. And yes, Doyle, that's exactly what I was saying in how SQL Server optimizes. It sees that unique criteria and basically disregards all the other stuff. Absolutely. There we
And then
go.
I'm going to have you scroll up just a little tiny bit because I answered
Oh,
one
okay.
and I didn't mean to. So am I correct in assuming that a modify of the stored procedure invalidates the previous plan cache?
Yes, Alberto, that's true. Anytime you alter a procedure, that also does plan invalidation. So absolutely. There's a lot of stuff that can do plan invalidation, but absolutely altering the procedure does. Thank you. I missed that. How much IO would you have to save to make a recompile worthwhile? What's your tipping point? Matt, you have been in my lectures before using the word tipping point. So that's a great question. And unfortunately, there isn't a good answer for that one. Obviously, when procedures are only doing, 10 IOs, 15 IOs, the cost of recompilation is probably going to be pretty darn close. But it also depends on the frequency of execution. It depends on how many times you might not need to recompile. Almost always, the execution of a really bad plan is far more expensive than the cost of a recompile, but you'd have to do some testing in your environment and get some insight into the frequency of the execution. It's a really, really tough question. But I would start saying, as you start to get into hundreds of IOs, you probably would find that recompilation would be less. But it depends, because if it's a really complicated statement to compile, then it could actually take a lot more time. So this is really, I would only focus on the procedures where you see wild variations. Like I've had cases where stored procedures take sub-second for some executions and take like 27 minutes for some executions. When it's that kind of a difference, it becomes a no-brainer. Instead of 27 minutes, we recompile and it takes 6 seconds, something like that. So I would focus on the wildest variations of your procedures and the ones that have the most frequent executions. But that's a really tough one. Okay, I think I got most of those. I apply help and support to learn more about this basic online skills such as creating online. I don't know what that means, actually. Glenda, do you even know what I apply help and support to learn more about this basic online such as?
Yeah, I'm not sure. I
Okay.
figure I'll email them later. So
Yeah. Okay. And
I
then,
think we're down to three. Remedy for the tempdb full was to try to clear the cache and then shrink it instead of the restart. That was the reason I was wondering about the cache, is what Sri was saying.
are we down at the bottom then? Okay. Remedy
Yeah.
for TempTV full was to try to and then shrink it instead of Restart. Interesting, Shri. Clearing the procedure cache when the tempdb is full is an interesting one. I mean, that shouldn't have done it, but it could have been that when you cleared the procedure cache, it made space for tempdb to grow, because the procedure cache will use from the buffer pool, but if the buffer pool is available, it'll go to tempdb. So it could have just been that you got lucky clearing the cache if you have a lot of memory, and maybe you gave 30 meg, or sorry, even gigabytes, 3 gig, 5 gig to tempdb that you needed, and then it seemed like that fixed the problem. I would go back again and do root cause analysis on why tempdb was full, and you might be able to optimize that scenario a lot better than clearing the cache to do it. But I could see where clearing the cache might give you a false positive, in that it allowed tempdb to finish or do whatever you were doing, and then kind of cleared whatever was taking up all that space in tempdb, and then things kind of quote unquote went back to normal. So I might also argue that allowing tempdb to grow larger, I mean, maybe your tempdb is just not optimally sized, and there's lots of good things to do to optimize tempdb, like multiple equally sized files that have the same growth rate. There's actually a really good white paper. If you just search for, actually his name is, was it Shri? No, who wrote that white paper? I can't remember, but there is a really good white paper out there on optimizing tempdb, and I can see if I can, if you just do, actually, I'm gonna just steal from our SQL skill site, because we have a, okay, that's not a good sign. Why is that not showing up? Okay, so something's wrong there. But if you go to SQL Skills, I don't, we had an issue yesterday, and they might be restarting the server, oddly, right at this time is annoying.
Of
But
course.
yeah, of course. So anyway, there's a resources page, and anyway, optimizing, let's just see if I can do it quickly. Optimizing tempdb SQL Server white paper. How to optimize tempdb in SQL Server. That looks like, I mean, I don't know what dzone is. I'd go to the docs one, tempdb SQL Server docs, and look at that. You know, it tells you a little bit about what it does, but there's definitely some good stuff on optimizing tempdb. Okay. Even though tables are pinned in memory, stored procedure can't run fast. Karthik, I'm going to need more information, because tables aren't pinned in memory. We haven't had a pinning option for a while. The only option that you can have are the in-memory tables, which is different from pinning a table in memory. And with a memory optimized table, the stored procedures have to be written a certain way so that they are fast. So I don't entirely know what you mean by even though tables are pinned. I mean, tables, maybe what you're saying is even though tables and data stays in memory as it's being used, why wouldn't the stored procedure run quickly? And the answer would be a lot of what I just said. Okay, so, oh, you put in there. Oh, interesting. Okay, so HTTP:/SQL skills. No, it's not working. I don't know why it's not working for me, but it looks like it's working for you guys. Oh, you're putting the dub as well. But why? Oh, yeah, I'm on SQL skills here. Why is that? How funny is that? Okay, so there you go. My gosh, I don't even know how. Oh, wow, this is really big. Let's subtract down. Okay, resources. And I was just going to say, if you look at our resources page, we've got a white papers page, and that has tons and tons and tons and tons of links. And if you just search for like tempdb there, I thought I did tempdb. You know, you can find that white paper, or find on page, I don't know. There we go. You can see those. It's searched across the whole thing. But if you search for tempdb, you can get to the tempdb white paper there. Okay, so good. Relevance to memory optimized tables and natively compiled procs. Different, totally different, Doyle. And I didn't get into memory optimized tables and the compiled procs. So sorry about that. That's a whole nother discussion. I mean, there's certain restrictions on the table, certain things that you can and can't do. There's certain durability impacts. So that's a whole nother can of worms with a whole different set of things that you should do and shouldn't do. So I just didn't get to that. So, and then Katie's question's funny. With regards to SP recompile, I have found that using it against tables or views is useful too. Do I have any input on that? Yes, Seth, that's a great comment. Just be careful. It is incredibly useful on tables and views, but remember that SP recompile doesn't actually recompile anything. It does something called plan and validation. And the way that it does it is it has to do something called a schema bump. And that schema bump actually requires a schema mod lock against the object that you're recompiling. So if you do SP recompile production table, they have to put a lock on that table, and specifically a schema modification lock against that table. So if you do an SP recompile against a production object at 10 o'clock in the on a Monday morning, you could create a massive blocking problem. So I love SP recompile, especially in against tables and views and so forth in maintenance operations and off hours. But I would just say be careful against doing it during the day, during production hours, especially against a very volatile, very active table. Is it a good practice to recompile the procedures as part of our maintenance procedure? Well, recompiling a procedure for some procedures needs to be done very frequently, and for some procedures, not at all. So I would argue that there isn't a good generalization. I would make it more in the code so that the procedure behaves as the procedure needs, as opposed to trying to sit something on top of it that wouldn't know, how to deal with the procedures accurately. So that's a tough one. I would say there is no good way to generalize it. And if you did just, let's say, recompile all of your procedures every night, or more simply, let's say you just cleared the cache every night, something like that, which would effectively get rid of all the procedures, you could still have all sorts of parameter sensitivity problems depending on who gets there first the next morning. So that is again just kind of a one-time solution, but it wouldn't solve production problems. So the better practice is to deal with the recompilation in the code. Okay, and I got that. I got the memory optimized one. All right, hey, I think I got it. Let me scroll again. I keep scrolling to the top accidentally. No, this is good. This is good.
That's
I
it.
think
Yep.
I got it. Woohoo! 42 minutes, although I ended about 10 minutes late. So 30 minutes of questions, but awesome. Sorry, I was looking at the chat window the whole time and I'm like, wow, nobody's asking any questions. I had the chat window like up on my screen and everything, and I was watching it. I forget that GoToMeeting has a separate questions window, whereas WebEx just has a chat window. So sorry about that, but this is
Makes
great.
sense.
Yeah. No, this is great.
Big thank you to Kimberly. I know a lot of people had a lot of information out of this, so thank you very, very much.
Yeah, you're welcome. This was fun. Yeah, great questions, you guys. So
make sure you guys check out dbafund.org to get the whole list of further all of our next sessions and such like that. Sorry, tongue tied a little bit there. And this will be up in YouTube channel, dbafundtube.org, within a couple of days. If you are needing the scripts and all that kind of stuff, I know she was showing her blog posts and stuff, but you can always also email us at dbafundamentals@pass.org, and we'll make sure we pass it on to you.
Oh, is that what you do? You give them the scripts directly?
I think there's something else we do, but I can't think of off the top of my head. So I'm just like,
Okay.
just email me and I'll get you the information.
Okay. Well, I'll send everything off to you guys, and then you guys can decide. Hopefully, maybe just put it up with the YouTube stuff, but I don't know if you can, or at least a link, maybe.
We do.
Oh,
It'll
good.
be up
Okay.
there with that.
Oh, perfect. Okay.
See, I knew we did something. I just totally forgot. So
I figured, but I didn't know. Awesome. All right.
All right, everyone, have a great day.
Thank you.
Thank you,
Bye-bye.
Kimberly. Thanks.